Most of the world has never seen what we are about to show. Today, we take you inside one of Iran's most secretive military factories, where the IRIS Dena warship was built. From raw steel to a fully operational naval combat vessel, you will witness every step of construction. Every detail here shows Iran's naval strategy and the human effort behind it. Stay with us. What you see next is rarely documented. The journey begins at the steel fabrication hall. Massive sheets of naval-grade steel lie ready for shaping. Machines roar as plates are cut and bent with precision. Workers measure each section to exact specifications before welding begins. Sparks fly as welders join pieces together, each seam ensuring structural integrity. This hull, these beams, are the backbone of a vessel, designed to withstand combat and rough seas. Every millimeter counts. One mistake here could compromise the ship's stability or performance. From the steel hull, we move to the assembly bay. Here, massive ship modules take shape. Each block weighs tons, lifted by giant cranes and positioned with meticulous care. Iran's modular construction method allows internal systems to be installed. Plumbing, wiring, weapons mounts to be installed inside each section before joining. This approach reduces build time and ensures the interior is fully functional. Workers navigate narrow corridors inside these modules, connecting hundreds of electrical lines and meters of piping, all under strict quality control. The bulkheads divide the ship into specialized compartments. Crew quarters, weapon bays, engine rooms, and storage spaces are all predefined. Engineers walk through each section, checking dimensions, alignment, and wiring. You can see how the ship's layout balances operational efficiency with survivability. Next, the engine room. The IRIS Dena is powered by 4 Banyan 4 diesel engines, producing over 20,000 horsepower combined. Technicians install fuel lines, exhaust pipes, cooling systems, and hydraulic controls. Each engine is calibrated for maximum efficiency, as any misalignment could cause catastrophic failure at sea. The roar of these engines hints at the power that will drive the vessel. We move to weapons integration. IRIS Dena is outfitted with multiple systems: anti-ship missiles, surface-to-air missiles, and torpedoes, a 76mm naval gun, and close-in weapon systems. Missile launchers are staged and tested on rigs, simulating real-life conditions. Technicians fire control signals to verify targeting systems. Engineers work on radar and fire control systems, aligning them to guarantee accuracy at sea. Every system must communicate seamlessly with the ship's central combat computer. Electronics are next. The ship features the ASR phased array radar system, capable of tracking multiple targets simultaneously. Navigation consoles are installed and tested. Technicians measure signal strength, interference, and latency. These systems allow the crew to detect threats beyond the horizon. Precision here is critical. A single faulty connection could compromise combat effectiveness. Inside the hull, electricians and plumbers work in parallel. Hundreds of kilometers of cable are routed through conduits. Pipes for fuel, hydraulics, and firefighting systems are fitted. Engineers cross-check each connection and every seal. The level of detail ensures the ship can survive in combat scenarios. Next is painting and exterior finishing. The ship receives protective coatings against corrosion, along with radar-absorbing paint. The gray paint is standard for naval stealth, allowing the vessel to blend with the sea horizon while maintaining durability. Crew training begins before the ship even leaves the factory. Simulators replicate every system on board. Sailors practice navigation, weapons operation, and emergency response. By the time the ship reaches the water, the crew is ready. Quality control is continuous. Inspectors use ultrasonic testing to check welds, electronics, and mechanical systems. Components must pass multiple tests before installation. This rigorous inspection minimizes the risk of failure during operations. The command bridge is another highlight. Rows of screens, radar displays, and control panels form the operational heart of the warship. Officers will steer the ship and manage combat operations from this space. The bridge represents the interface between human decision-making and machinery. Final assembly brings all elements together. Modules are joined, weapons and radar systems mounted, and electronics calibrated. Cranes lower superstructure components onto the hull. This stage transforms individual components into a fully operational warship. Footage from the launch area shows the completed ship moving toward water. Workers line the dock, watching months of labor enter the sea. The hull gleams under the factory lights. This moment marks the transition from construction to deployment, from theory to reality. IRIS Dena entered service in 2021 as part of the Iranian Navy's strategy to project power in the Gulf. Displacing roughly 1,500 tons, the vessel carries missiles, torpedoes, and a helicopter for patrol and anti-submarine operations. It is a symbol of Iran's domestic engineering and military capacity, demonstrating the ability to build advanced naval assets under international sanctions. In early 2026, the vessel gained international attention when it was reportedly struck by a torpedo from a submarine in the Indian Ocean. This rare engagement highlighted both the ship's capabilities and vulnerabilities, showing that even advanced warships face significant risk in modern naval warfare. This look shows the intersection of engineering and strategy. From steel plates to a sophisticated warship, every step represents effort and strategic intent.